For over 350 years, a storm bigger than our entire planet has been raging on Jupiter. It's a crimson eye, staring out into the void. A maelstrom so vast, so powerful, and so long-lived that it has become the most iconic feature in our solar system. We call it the Great Red Spot. For centuries, we saw it as a permanent fixture, a testament to the raw, untamable power of the cosmos. A storm without end. But what if I told you? It's dying. And scientists are racing to figure out why. This isn't just a theory, this is based on observation. The colossal tempest that could once swallow 3 Earths is fading right before our eyes. Its edges are fraying, its size is shrinking, and its once mighty oval shape is becoming a ghost of its former self. We are witnessing the death of a giant. The question is no longer if it will vanish, but when, and what is the killer? This is the story of a cosmic crime scene, an investigation stretching across hundreds of millions of miles, as we hunt for the culprit that's dismantling the king of all storms. Before we get into its mysterious decline, we have to appreciate what the Great Red Spot really is. Calling it a storm is a serious understatement. It's an anticyclone, a high-pressure system of swirling gas, so immense that it makes our weather look tiny. Imagine the most powerful Category 5 hurricane on Earth, with winds around 157 miles per hour. The Great Red Spot's winds at its high-speed outer edge can scream at over 400 miles per hour. Its scale is even more mind-bending. When astronomers started making detailed observations in the late 1800s, the Great Red Spot was a breathtaking 25,000 to 30,000 miles across. At that size, you could line up 3 Earths side by side and they would fit comfortably inside its swirling chaos. It was less a spot and more a gigantic crimson scar on the face of the gas giant. It wasn't just a feature on Jupiter. For many, it was our image of Jupiter. This storm is an engine of unimaginable energy, a vortex that has lasted for generations. While storms on Earth are born from warm ocean water and die out over land in days or weeks, the Great Red Spot has no land to slow it down. It's a self-sustaining atmospheric machine powered by Jupiter's internal heat and its incredibly fast rotation. A day on Jupiter is less than 10 hours long. For centuries it seemed eternal, a symbol of permanence in a violent solar system. But that idea of permanence was just an illusion. The giant has been wounded, and the evidence of its decline is impossible to ignore. Our investigation into the red spot's shrinking starts not with modern spacecraft, but with patient sky watchers from history. While some old records suggest a permanent spot was seen as early as the 1600s by astronomers like Giovanni Cassini, a recent historical analysis suggests that storm probably disappeared. The Great Red Spot we know today seems to have formed later, with consistent observations starting around 1831. This fact alone is a huge clue. Even these monster storms on Jupiter might not be immortal. They can be born and they can die. For its first century of reliable observation, the storm was a behemoth, but then things started to change. When NASA's Voyager 1 and 2 spacecraft flew by Jupiter in 1979, they gave us our first incredible close-ups. They also delivered a startling measurement. The spot had shrunk to about 14,500 miles across. still big enough to swallow Earth but a lot smaller than its historical peak. The decline was underway. Through the 90s and 2000s, the Hubble Space Telescope kept a close watch, confirming the trend. By 1995, it was 13,000 miles across. By 2009, just over 11,000. Then starting around 2012, something alarming happened. The rate of shrinkage suddenly sped up to about 580 miles per year. The storm wasn't just shrinking, it was shrinking faster than ever. Today, recent Hubble data puts its width at a mere 10,159 miles. Less than half its size from the 19th century, and now only able to fit one Earth inside it. The grand oval has become more circular, a wounded version of its former self. This acceleration is the smoking gun that has sent planetary scientists scrambling for answers. To understand what's killing the giant, we needed a closer look at the crime scene. We had to go beyond what telescopes could show us from Earth. We needed robots to be our detectives, and in the last decade they've given us an amazing view of the storm's troubles. Our first key witness is the Hubble Space Telescope. For over 30 years, it's been tracking the storm's health. In 2019, Hubble saw dramatic flaking, where huge streamers of red cloud were being peeled away from the main storm, like blades snapping off a turbine. At the same time, Hubble revealed a paradox. Even as the storm shrank, the wind speeds at its outer edge were actually getting faster, increasing by up to 8% between 2009 and 2020. It was as if the storm was tightening its belt, spinning faster as it got smaller. But to really understand a storm, you can't just look at the top. You have to look underneath. That's the job of our lead detective, NASA's Juno spacecraft. Arriving at Jupiter in 2016, Juno was built to peer below the planet's thick clouds. For decades, scientists wondered if the Great Red Spot was a shallow weather event or a deep vortex stretching far into the planet. Juno gave us the answer. Its measurements showed the storm is far deeper than anyone expected, reaching down an incredible 300 to 500 kilometers or up to 310 miles into the atmosphere. To put that in perspective, the International Space Station orbits Earth at an altitude of about 250 miles. The Great Red Spot is a storm deep enough to swallow our planet from the ground all the way to our astronauts in orbit. But Juno also found that the powerful jet streams that fence the storm in, feeding it energy, go even deeper, down to almost 3,000 kilometers. This tells us the storm is a massive weather system, but it's connected to and at the mercy of even bigger and deeper forces inside Jupiter. And just when we thought we had a handle on it, a new investigator arrived. The James Webb Space Telescope. In mid-2024, Webb aimed its powerful infrared eyes at the region above the Great Red Spot, an area scientists thought would be totally boring. What it found was stunning. The area was alive with complex, never-before-seen structures, bright spots and dark arcs rippling through the upper atmosphere. Scientists now think these are the result of powerful gravity waves churned up by the violent storm hundreds of miles below. These waves travel upward and break like ocean waves on a beach, dumping their energy into the highest parts of the atmosphere. The Great Red Spot isn't just a storm in the clouds. Its influence reaches all the way to the edge of space. So now we have the evidence. a shrinking, flaking storm that's spinning faster at its edges, rooted deep in the atmosphere but influenced from below, and so powerful its effects are felt hundreds of miles above. It's time to line up the suspects. This is a cosmic mystery playing out in real time. If you're finding this investigation as cool as we do, take a second to subscribe and hit that notification bell. You don't want to miss our future trips into the biggest questions in the universe. Your support helps us keep breaking down these huge scientific discoveries. Now back to the suspects. With the evidence on the table, it's time to look at the prime suspects in the case of the dying red spot. Suspect #1, starvation. For a long time, scientists thought the Great Red Spot ate smaller storms that got too close, using them as fuel. It was a kind of atmospheric cannibalism. But new simulations from 2024 have flipped this idea around. The new theory is that the storm needs this diet of smaller storms to stay strong. These aren't just snacks. They're a lifeline. When a smaller vortex gets absorbed, it injects energy into the big storm, helping it fight off decay. The simulations show that without a steady diet of these smaller storms, the Great Red Spot naturally loses energy and shrinks, so the killer might not be an active attacker but a change in the menu. If Jupiter's storm nurseries aren't making as many small storms for the Great Red Spot to eat, then the giant is simply starving to death. Suspect #2, the power grid is failing. As Juno found, the Great Red Spot is a 500-kilometer deep storm, but it's powered by jet streams that are nearly 3,000 kilometers deep. These jets are like two massive conveyor belts on either side of the storm, flowing in opposite directions. The friction between these two flows is what spins the Great Red Spot and keeps it going. But what if that power grid is having problems? Any small change in the speed or path of these deep jet streams could mess with the storm's energy supply. If the jets are providing less power, it could be slowly choking the storm of the momentum it needs to live. Its deep roots make it powerful, but they also make it vulnerable to changes in the planet's deep interior that we're only just starting to see. The power could be getting cut off at the source. Suspect #3, it's simply old age. Maybe we're not witnessing a murder but a death from natural causes. The fact that the permanent spot from the 1600s probably vanished and was replaced by the current one tells us these things have a life cycle. They're born from chaos. They live for centuries and then they fade away. Nothing in the universe is truly forever. The storm's shrinking might not be caused by any one thing but by its own internal machinery finally wearing down. Like a spinning top that's been going for nearly 200 years, it might just be running out of energy. After centuries of raging, the Great Red Spot might just be tired. Its decay may be the natural, inevitable end to its long and violent life. The general feeling among scientists is that it's probably not one single culprit, but a combination of things. A smaller diet of storms, mixed with small shifts in the deep jet streams, are all likely contributing to the storm's slow, natural end. At this point, you might be thinking, this is all interesting, but it's happening on a planet 400 million miles away. Why does a storm on Jupiter matter to us? The answer is that the Great Red Spot is more than just a storm. It's a cosmic laboratory. By studying how it works, we learn about the basic physics of atmospheres in extreme conditions. In fact, research into what keeps the Great Red Spot going is helping us understand weather right here. Recent studies have shown that the way the red spot absorbs smaller storms to keep itself going is mathematically similar to how long-lived high-pressure systems on Earth, which we call heat domes, are strengthened by nearby weather systems, leading to extreme heat waves. Understanding Jupiter's weather gives us a new way to look at our own climate. On top of that, Jupiter is the model for all gas giants. The lessons we learn from the Great Red Spot can be used to understand the thousands of giant exoplanets we're now finding around other stars. When our telescopes see a spot on a distant world, what we've learned from Jupiter helps us figure out what we're looking at, and maybe most importantly, the latest discoveries from the James Webb Space Telescope have totally changed our understanding of how planetary atmospheres work. Finding that the storm is creating gravity waves that ripple hundreds of miles up shows that a planet's weather isn't a simple layered cake, but a deeply connected machine. What happens deep in the atmosphere has huge effects at the edge of space. The Great Red Spot isn't just a cool thing to look at, it's a living textbook on planetary science, and its final chapters are being written right now. Even with all our advanced tech, the Great Red Spot still holds deep mysteries. The most obvious one is its color. Why is it red? Scientists still don't have a final answer. Theories guess that it could be complex chemicals pulled up from deep inside Jupiter that get zapped by the sun's radiation. But the exact chemical mix is still unknown. And of course, there's the biggest question. What happens next? Will it completely disappear in the next couple of decades, as some models predict? Or will it, as other scientists think, shrink to a new, smaller, more stable size and stick around for centuries, held tightly by its jet streams? The truth is, we don't know. But we're watching live. The investigation is still going. Every trip Juno makes, every new picture from Hubble and Webb gives us another clue. We are in a golden age of exploring the planets, watching another world change in real time. The story of the Great Red Spot isn't just about the death of a storm. It's about the scientific process itself, a huge mystery that we are slowly, piece by piece, starting to solve. For almost 200 years, the Great Red Spot has been a symbol of cosmic power and permanence. Now we know it's a dynamic, changing, and ultimately temporary feature. We're watching a landmark of our solar system fade away. The cause is likely a perfect storm of its own, a mix of starvation, a shaky power grid, and the simple, unstoppable march of time. Its end will dramatically change the face of Jupiter, a planet that will look very different to future generations than it did to us, but its legacy will be the incredible science it has taught us, changing our understanding of how planets work. What do you think is the main reason the Great Red Spot is disappearing? Is it a natural death, or is something more chaotic happening in Jupiter's clouds? Let us know your theory in the comments below. If you enjoyed this journey into the heart of our solar system's greatest storm, please give this video a like and subscribe for more deep dives into the cosmos. Thanks for watching.